Good day, students. Welcome to part 8 of the AP Calc AB multiple choice review questions for 1998. So we're going to be going over questions 86 to 92 in this installment. All right, so let's take a look at question number 86. So question 86, it says the base of a solid is a region in the first quadrant bounded by the x-axis, the y-axis, and the line x plus 2y equals 8, as shown in the figure above. If cross-sections of the solid perpendicular to the x-axis are semicircles, what is the volume of the solid? Okay, so this is basically assessing your understanding of solids with known cross-sections. All right, so we're going to make a sketch of the situation, but before I do that, let me label this function right here. So we're looking for the volume of the solid created by the base bounded by these functions, this function and the axis. So let's call this the top function. Since our segment is going to be perpendicular to the x-axis, it's going to look something like this. That's a cross-section of the semicircles. So we have this is a function on the top. I'm going to call this f of x, top. All right, we're going top down. And then at the bottom, this is g of x bottom. All right, so if we want to find the length of this segment, we just basically find the difference between these two functions. And one thing you want to note is that this function down here is basically the function y equals 0, all right? And then the top function is y equals 8 minus x over 2. I'll go over details as to how I got that later, but just note that this is the top and this is the bottom function. So can you visualize the solid that is being created here? To help you visualize it, let's go ahead and sketch the situation. I'm going to rotate my axis and just lay it down flat. So this is my y-axis and that's my x-axis, and that's the line y equals x. Let's put it like that. Okay, so what we have is so this is y, this is x. We have semicircles sitting right on this in such a way that they're perpendicular to the x-axis. So this is one of the semicircles. Let me draw one of them. So this is one semicircle perpendicular to the x-axis. Imagine that this is 90 degrees right here. Okay, that's 90. All right, so the semicircle looks something like this. Okay, so that's one of them. And then what's going on is that you have an infinite amount of semicircles just like that. Okay, so the question is, if you have a whole bunch of semicircles just like that over this entire region, what is the volume of that solid going to be? So that's what we're doing in this problem. Okay, all right, so in order to do this, we have to find the area, the cross-sectional area of our semicircle, and then we're going to evaluate an integral. Now you want to note that for this problem, we're going from 0 all the way to 8. So let's take a look at this segment, for example. So this semicircle right here has a diameter, okay? The diameter is d, and that d is basically the difference between the function on the top and the function on the bottom. All right, so it's basically f of x minus g of x, where f of x is the one on top and g of x is the bottom function. Okay, so f of x, you see this function right here. If I isolate it for y, x plus 2y equals 8. If I solve it for y, I'm going to have y equals 8 minus x over 2. So this is my top function. My top function is 8 minus 2x. I'm sorry, 8 minus x. 8 minus x over 2. And then my bottom function is the x-axis, which is y equals 0. Okay, so that's the diameter of our semicircle. Okay, 8 minus x over 2. Now, let's see. Let me write down the formula that we're going to use to find the area of the resultant solid. So generally speaking, if you want to find the area of solids with known cross-section, if you're dealing with semicircles, this is the formula right here. So let's put it in green. So formula. If you're going along the x-axis, everything is going to be in terms of x, okay? So the area is going to be the integral from the x to the leftmost x to the right. So in this case, this is the leftmost x0, and then the one on the right is 8 of, we're going to be doing pi r squared over 2, basically the area of a circle divided by 2. So pi of 1/2 of pi times the radius, okay? So what is the radius in this, what is the radius in this case of this situation? So the radius is going to be the function f of x, let's write that in like this, lowercase f of x minus g of x. So f of x minus g of x represents the diameter, right? But we need to find the radius. How do you find the radius if you know the diameter? You simply divide that by 2. Okay, f of x minus g of x over 2. So this is r quantity squared dx. So this is the formula for a semicircle. Okay, formula for a semicircle. All right, so if this formula looks a little bit too abstract for you, what we just did here is we just evaluated the integral from a to b of 1/2 pi r squared dx. That's what we did. So this entire expression right here is r squared. Okay. All right, so that's what we're going to be applying to this problem right here. We need to find out what the radius is. So what is our radius here? Radius is the diameter divided by 2. So our diameter is 8 minus x over 2. So 1/2 of that, 1/2 of 8 minus x over 2 will give us the radius of all semicircles. Okay? So it's going to be 8 minus x over 4. So there goes the radius. Now we're going to plug this into our formula. So if we plug into a formula, the area is going to be the integral. You know that x is going from left to right because our semicircles are perpendicular to the x-axis. If they were perpendicular to the y-axis, everything will be different. This would be all y's. Y here. Okay? Be completely different. And we're using a different equation. We'll be using x equals 8 minus 2y equation. Alright, so here we're going to start from 0, the leftmost x to 8, the one on the right, and then since it's a semicircle, 1/2 times pi r squared, and we know what r is. R is 8 minus x over 4, for the diameter over 2, square dx. Now this is a calculator section, so we don't want to waste our time trying to integrate this by hand. We're going to use our calculator to do it. So I'm going to be using a TI-89 titanium calculator. That's basically the best calculator for the AP exam. So let's evaluate this integral real quick. So the integral of 1 over 2 pi, 1 divided by 2 pi, parentheses, 8 minus x, 8 minus x, close the numerator, divided by 4, the denominator, close this expression right here, and raise it to the second power. And then the independent variable is x, lower limit of integration is 0, upper limit of integration is 8. Close that, enter. Well, it gives me the answer in an exact form. I need an approximation since my options here are approximate values. So diamond enter. 16.7552. So our answer we can clearly see is option letter C. Okay, so our answer is option letter C. Area is approximately 16.755. Alright, so the trick here is do not forget to divide your diameter by 2, okay? That will give you a wrong answer. Now let's take a look at the next problem. Alright, let's take a look at 87. It says, which of the following is an equation of the line tangent to the graph of f of x equals x to the fourth plus 2x squared at the point where f prime of x is equal to 4? Equals to 1. Alright, so basically, we're being told that the slope is 1, and we're asked to write down the equation of the tangent line. Alright, so to write down the equation of the tangent line, you just write down the point slope form of the equation of the line. Y minus y1 equals mx minus x1. So all we need is m, which we already know is 1. Remember, m is your slope, f prime. We need x1, and we need y1. Okay? So we know that the slope at x1, y1 is 1. So what is the x value that gives us an output of 1 for the slope? So all we have to do is we have to solve this equation. F prime of x equals 1. So what is f prime of x? How do we find f prime of x? We'll simply differentiate this function, right? So if f of x is x to the fourth plus 2x squared, then it follows that f prime of x, using the power rule for differentiation, is 4x to the third plus 4x. Okay, since f prime of x is equal to 1, we have to solve this equation. We have to solve 4x to the third plus 4x equals 1. This tells us the x value where the slope has a value of positive 1. Okay, so how do we solve this equation? There are different ways we can do it. One easy way, since we can use a calculator here, is by simply graphing the two functions and looking for the intersection. Alright, so let's go and do it. So we have, let's enter the first function, 4x to the third plus 4x. Enter. That's the first function. The second function is 1. Enter. And we're going to graph both of them. That one, F3 is the graph. So there goes the cubic function, and then the linear function should be coming up in a second. There goes the linear function. Okay, so what we're looking for is the intersection. So F5 gives you the access to all the calculation menus you can do on the graph. So option 5 is intersection. First curve, enter. Second curve, enter. Lower bound, any points to the left of the intersection will suffice. Upper bound, any point to the right of the intersection. Enter. And then the x value, 0.236. Or if we got to round it up to 3 decimal places, okay? So 0.237. So the solution here is going to be x equals 0.237. Now, if you're using the TI-89 titanium, there's a different way you can do this that's much quicker. So let me show you. From the home screen, all you just simply do is go to algebra, and then you select solve. F21 will give you the access to the solve function. Enter the function for x, actually the equation 4x to the third plus 4x equals 1. And then what variable are you solving for? You're solving for x. Enter. Boom. Okay, so if you have a TI-89 titanium, you have a computer algebra system here you can take advantage of to solve algebraic equations. But if you don't have a TI-89 titanium, you have a 83 or 84, you can just go to the graph menu and then do the steps I just showed you. Okay, so this is the x value where the slope of the tangent line is positive 1. So we have x1. Now that we have x1, we can skip steps and use a calculator to find the equation of the tangent line, or we can find x2 and write down the equation of the line. Okay, so if I want to be lazy, there's something I can do. I can graph the original function. Let's clear that, clear that, clear that. And then the original function is x to the fourth plus 2x squared. Enter. All right, you graph it. All right, so what you're looking for is the slope of the tangent line at x equals 0.237. Okay, so I'm going to go to F5, and option 6 says derivatives, dy dx, option 1. Now what this does is it calculates the slope and also gives me the equation of the tangent line. So it says dy dx at what x value? Let's enter it, 0.237. Enter, and voila, it gives us the equation. Okay, actually I used the wrong one. This tells me the slope. I need the equation of the tangent line. So let's go back to F5. I wanted to use this option right here. Scroll down to tangent. Okay, this is the one. So tangent, select that. So it says tangent at what? Point, yeah, 0.23. Let's put it again, 0.237. Enter. So it draws a tangent line for you, and it gives you the equation of the tangent line. Okay, so it's basically y equals, it approximates it, y1x minus 1.21, and then if you round it up, your answer is going to be, where's the calculator? Let's bring the calculator back up. So y equals 1x minus 1.22. Okay, actually it's 0.122. So 0.122. All right, so you can clearly see that the answer is option D. Now that's one way of doing it, to find the equation of the tangent line at any point on a graph with a known function. Now another way you can do it, if you want to do this by hand, it'll take a little bit longer, but if you want to do this by hand, we just have to figure out what y1 is. So y1 is basically f of x1, okay, which is f of 0.237. All right, so what is f of 0.237? That's what you get. Let's redraw the graph. That's what you get when you input 0.237 into your function. All right, so the graph is coming. There goes the graph. And then you're going to use the trace menu, trace, and then you enter 0.237 for your x, and what I need is the y. So my y is 0.115. Okay, so my y1 is 0.115, 0.115. Now I have my m, let's put this away. I have my m, which is 1. My x1 is 0.237, and my y1 is 0.115. Now I'll put all of this into my point slope equation of a line. So you have y minus 0.115 equals 1 times x minus 0.237. And if you solve this for y, you just basically add this to both sides. You have y is equal to x minus 0.122. Okay, if you subtract this from both sides, I mean, if you add this to both sides, that will be your final answer. So you can use a shortcut, or you can do it using the long method. All right, let's move on to question number 88. So for 88, it says let f of x be an antiderivative of the natural logarithm of x to the third over x. If f of 1, the antiderivative at 1 is equal to 0, then what is the antiderivative at 9? So we can easily use FTC part 2 here to solve this problem. So remember that from FTC part 2, that the antiderivative at let's use from B, antiderivative evaluated at B minus the antiderivative evaluated at a is equal to the definite integral from a to b of the function f of x dx. In this problem, f of x is equal to the natural logarithm of x to the third over x. Okay, and b is the upper bound, which is 9, and a is the lower bound, which is 1, the arguments of our antiderivative functions. So let's set up the integral. So using FTC2, we can see that the antiderivative at 9 minus the antiderivative at 1 is equal to the integral from 1 to 9 of the function natural logarithm of x to the third over x. All right. So let's see. We're looking for, what are we looking for? We're looking for f9. So we can just add f1 to both places. So this implies that antiderivative at 9 is equal to the integral from 1 to 9 of the natural logarithm of x to the third over x plus the antiderivative evaluated at 1. All right. So we can plug this in our calculator. We know that f of 1, the antiderivative at 1 is 0, so we can just even drop that off. That's 0. So we just plug this in our calculator, and that will give us our final answer. All right, so calculator's out. Let's go back home. We're looking for a definite integral here. Second function 7, integral of, parentheses, the natural logarithm of x, equals a logarithmic function. Group the numerator and raise it to the third power. Divide that by x. Okay, let's start this calculator again. I'm having some problems here. Alright, divided by x. Independent variable is x. Lower limit of integration is 1. All the way to 9. Close that. We need an approximation. Diamond enter. .827. Okay, so f of 9 is 5.827. Let's write that down. It's approximately 5.827 to 3 decimal places. Our answer is option C. All right, let's take a look at the next problem, problem number 89. So it says if g is a differentiable function such that g of x is less than 0 for all real numbers, so g of x is always negative, and if f prime of x is x squared minus 4 times g of x, which of the following is true? So you have situations here about max and min of the function. Now, how do you determine relative max and min? What you do is you find the critical points, and then you set up your number line and look at the signs, right? So the critical points are where you have the derivative having a value of 0, or you have a non-existent derivative that's corner cusp of vertical tangent or no tangent at all, okay, or discontinuity. All right, so let's look at this. In this problem, we're focusing mainly on the critical points associated with this function right here. So if you set this component of the derivative x squared minus 4 to 0 and you solve it, you're going to have x is equal to plus or minus 2. Okay, this can generate some critical points, but we don't really need it to answer this problem. So what we're going to do is make a number line, and let's graph our critical points. We have -2 and 2. So these are the points where the derivative obviously is equal to 0. Okay, now in order to determine if it's increasing or decreasing, we're going to break it up into 3 intervals: interval 1, interval 2, and interval 3. We need test numbers for each interval. So for this interval, we can use x equals -3. Here we can use x equals 0. And here we can use x equals +3. All right. So we want to look for the sign of f prime on this interval, then we can determine the behavior of this extrema here. Okay. Now, we can plug in these values into this function to determine the sign, or we can just look at the behavior of the graph. Okay, so what we're looking for here is the sign of f prime. Interval number 1, x is equal to -3. So when x is equal to -3, we're looking at x squared minus 4 times g of x. Now, let's look at the graph. Let me just sketch the graph for you real quick. That's an easy way you can solve it. So if you sketch the graph of x squared minus 4, it's a parabola that's shifted 4 units down. So let's see, this is -4 right here. And the y-intercept are the roots we just got, -2 and 2, I'm sorry, the x-intercept. So it looks something like this. All right. That doesn't look good. Let's try again. So something like this. All right, so what this shows us is that when you are at interval 1, this quantity is positive, okay? But when you're between -2 and 2, it's negative, and then when you are bigger than 2, it's positive. All right, so we can use that here. So for x squared minus 4 in interval 1, this is minus. How about g of x? What's the sign of g of x? Wait a minute, the problem, we're told earlier that g of x is always less than 0. So regardless of where you're at, g of x will be negative. So here it's going to be negative. Negative times negative is positive. So, okay, I think I made a mistake. It's x squared minus 4 is positive here. And then g of x is negative. All right, so negative times positive is negative. Interval 2, we use x equals 0. You can look at the graph, or you can plug it in here. If you plug it in here, you can see you have -4. If you look at the graph, you're beneath the x-axis, so it's negative. So x squared minus 4 is negative here, and g of x is always negative. When you multiply these two, you're going to have minus times minus, which is positive. Okay? Now, lastly, we have interval 3, x is equal to 3. This is positive on that interval, and then g of x is negative. Always negative. Multiply these two, you have minus. All right, so these are the signs, whichever way you want to do it. So for example, look at this one right here. It's positive, negative, positive. So since g of x is always negative, what it does is it just flips this pattern into negative, positive, negative. That's another shortcut you can use. All right, so let's see. We have interval 1. This, what is it? It's negative, negative, and then positive, and then negative. All right. So what do these signs tell me about the behavior of f? Now that we have the sign of f prime, what does the sign of f prime tell us about the behavior of f? Behavior of f. We know that when f prime is negative, the function is decreasing. When it's positive, the function is increasing. When it's negative, it's decreasing. All right. So when you're decreasing and increasing, what kind of extrema do you have here? At -2, you have a minimum. All right, a relative minimum. And here, if you're increasing and decreasing at 2, you're going to have a relative max. All right, so let's see which one is the correct answer. Relative max at, no, relative mean at x equals -2 and relative max at x equals 2. Excellent. Our answer is option letter B. All right, let's take a look at our next question, 90. It says, if the base B of a triangle is increasing at a rate of 3 inches per minute, while its height is decreasing at a rate of 3 inches per minute, which of the following must be true about the area of the triangle? So this is a related rates problem on the area formula of a triangle. Okay, so what's the area of a triangle? Area of a triangle is 1/2 base times height. So since both variables are changing, we're going to differentiate implicitly. Okay, so the derivative of a is just 1 dA dt, and then we can factor out the 1/2. These two are variables. None of them are constants, so we have to differentiate them, treat them as variables. Since they're two variable functions, we have to use the product rule here. uv prime, we recall, is vu prime plus uv prime. You can say uv prime plus vu prime. It doesn't matter because we know that the addition commutes, okay? So let's go ahead and do that. So v is h. The derivative of v is just 1 dB dt plus u. Let's write this down so we don't get confused. This is u. So this is u right here. V is u, and h is v. Okay? Alright, so now we have u, which is h, and u is v, and then the derivative of v is 1, and then using implicit differentiation, dh dt. Alright, now we're told that the base is increasing at 3 inches per minute. So this value right here is dB dt, the change in the base per unit time. And the height, this one right here, so this one is increasing, so it's positive, and then this one is decreasing, so it's going to be negative, and then this is dh dt, the change in the height. All right, so let's put in those values into our equation. So we have the ADT, which is the rate at which the area is increasing or decreasing, is 1/2 times h dB dt is positive 3 plus the base b times the h dt, since it's decreasing, is negative 3. Okay, so we have this equation here. So the question is, which of the following must be true about the area of the triangle? All right, so we need to find, we need to pick what we want to find out. We want to find out the conditions for where the ADT is increasing or where it's decreasing. Now, what you want to note is that if we're looking at increasing, we're going to look for where the ADT is greater than 0, and decreasing, we'll look for where the ADT is less than 0. Okay, so then how about we pick decreasing, since I have decreasing here, and decreasing. So A is decreasing when the derivative, the ADT, is less than 0. Remember, we talked about this before, the connection between the sign of the derivative and the function. If the derivative is negative, that means the function is decreasing, okay? So in order to solve for when the area is decreasing, we're just going to set this expression to less than 0. So let's go ahead and do that. Simplify it a little bit. So we'll have, we want to find where 1/2 of 3h minus 3b, when is this less than 0? Whenever it's less than 0, we know that the ADT is less than 0, since the ADT is equal to this expression right here, okay? So multiply both sides by 2, we have 3h minus 3b is less than 0. Add 3b to both sides, 3h is less than 3b, and then divide both sides by 3, h is less than b. So whenever h is less than b, that implies that the a dt is less than 0, which implies that a is decreasing. All right, so when h is less than b, h is less than b is equivalent to saying b is greater than h, right? So when b is greater than h, the area is decreasing. So we clearly see that the answer is option letter D. Okay, so that's that. All right, let's take a look at question number 91. It says, let f be a function that is differentiable on the open interval 110. If f of 2 is equal to negative 5, f of 5 is equal to 5, and f of 9 is equal to negative 5, which of the following must be true? Now we have differentiability on this open interval. That means that within this interval, the function is going to be continuous, and there are not going to be any corner, crosses, or vertical tangents. All right. So we have these points right here. Let's make ourselves a chart to organize this information in a way that's easy to understand. So we have a chart. We have three inputs, 2, 5, and 9 as our x's, and then our f of x are our outputs, negative 5, 5, and negative 5. Now let's give ourselves a possible sketch. This is not the only, this is not the exact sketch. This is one of the possible sketches that satisfies this description here. So let's sketch the graph of the situation. X goes from 2 all the way to 9, and then, okay, from negative 5 to 5. Let's put it in the center somewhere here. Okay. All right, so let's graph the points. So 2, negative 5, 1, 2, 3, 4, 5, 2, negative 5, that's 1 point. And then we have 5, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And then the last one, this is 5, 2, 6, 7, 8, 9. 9 takes you right back to 5, negative 5. Okay? All right, so this sketch can help us really understand what's going on here. Since this function is differentiable from 1 all the way to 10, a much bigger interval, we know that this is going to be smooth, so we don't have any cross or any weird things happening here. So we can assume that it looks something like this. This is a possible sketch. Goes like that, and when it hits that maximum, it better be smooth, or else it's not differentiable. So smooth right there, and then it could look something like this. Okay, so this is a possible interpretation. Now looking at this graph, let's see what conclusions we can draw using these options right here. So it says f has at least 2 zeros. Is that possible? If you look here, we're guaranteed to have a 0 somewhere between 2 and 5, and another 0 between 5 and 9. We can conclude that this is accurate using the intermediate value theorem. Okay, since this function is continuous on this interval from 2 to 5, and it attains values of negative 5 and 5, the function must attain every value in between 5 and negative 5. So since 0 is in between 5 and negative 5, we're guaranteed to have a 0 between 2 and 5. Same argument here. Using the intermediate value theorem, since the function is continuous on this interval, and it goes from 5 to negative 5, it must also attain the value of every value between 5 and negative 5, which includes 0, and that's another 0 right there. So we have 2 zeros on this interval. Now the next option says that f has at least one horizontal tangent. Now let's think about the extreme points that we have. 2 and 9, we can have a closed interval there. What do we have in this situation? We have a horizontal tangent line. Okay? So if the endpoint has a horizontal tangent line, what can we guarantee to have somewhere in between here? You remember the mean value theorem? So the mean value theorem tells us that if you draw a secant line on any function that's continuous on an open interval and differentiable on that closed interval, you draw a secant line, the slope of that secant line, there's going to be a point in within that interval where the slope of the tangent line is equal to the slope of the secant line. All right, so what is the slope of the secant line on from 2 all the way to 9? We can clearly see that the slope of the secant line is 0. So m here, the slope of the secant line is 0. So m is equal to 0. So f of b minus f of a, remember that for the mean value theorem, over b minus a, the slope of a secant line, in this case, is equal to 0. So there has to exist a c, there has to be a c in AB where f prime of c is equal to 0. This is by the mean value theorem. So this is true by the mean value theorem. To be specific, this is a special case of the mean value theorem known as a Rose theorem, okay? So since the slope of the secant line has a value of 0, there must be another value in between 2 and 9 where the slope is also 0. So that guarantees that we have at least one horizontal tangent line in this interval. All right? And then lastly, it says between 2 and 5, f of c is equal to 3. So let's look at 2 and 5. 2 and 5 has values from negative 5 to 5. So by the intermediate value theorem, we guarantee that this function attains value, sorry about that, attains every value in between negative 5 and 5. So is 3 in between negative 5 and 5? Absolutely. So by the intermediate value theorem, we can also conclude that this statement is true. So all these three statements are correct. So our answer is option letter E. All right. Let's move on to the last question. So this one says if k is between 0 and pi over 2, and the area under the curve of y equals cosine x from k to x equals pi over 2 is 0.1, then what is the value of k? All right, so we know how to find the area underneath a curve. We use a definite integral. So what we have here is a situation. Let me go ahead and set it up for you. So we have the integral from some value k all the way to pi over 2 of the function cosine x dx equals 0.1. So the question is, what is the value of k? So to set up this equation, this integral setup into a solvable equation, we're just going to apply FTC2 to the left side, okay? So let's evaluate the antiderivative of this function. If you evaluate this, it's going to become the antiderivative of cosine, the sine, negative sine x. Oh, sorry, it's positive sine x. So if you integrate if you integrate cosine, you have sine. So we're evaluating this antiderivative from k all the way to pi over 2, and that is equal to 0.1. Now applying FTC part 2 to this expression, we're going to have sine evaluated at the upper limit, pi over 2, minus sine evaluated at the lower limit, which is k, and that is equal to 0.1. And then sine of pi over 2, we know that sine of pi over 2 is 1. So we're going to have 1 minus sine k is equal to 0.1. We can subtract 1 from both sides. We have negative sine k is equal to negative 0.9. So sine k is equal to 0.9, and k is the inverse sine of 0.9. And then when you plug that in your calculator, k is approximately 1.120. All right, so that's that. So thanks so much for taking the time to watch this presentation. You can feel free to subscribe to my channel, and please post a comment to let us know what you think about this presentation. More clips come from mathcoachserve.com. Thanks again for watching and have a wonderful day.